Okay, so just a friendly reminder, is this on your quiz tomorrow?
No.
No. Good. Okay, so today we're going to talk about function composition, okay? Meaning taking one function and putting it basically in another function, okay? So the way you'll see it written are either of these two ways, and both of them are read f of g of x. Okay, this one too, f of g of x. This is like a little mini O. It's in the middle of the row of the line, okay? And it kind of looks like fog, but it's really just an open circle in the middle, okay? So I want you to think for a minute. If I asked you to do f of x, what is the input? X, and we plug it into the function f, right? Okay. This is the same idea. X is still the input for g of x. You see that? Think of it as like its own inside function. So x is still the input for g of x. But then all of g of x is the input into what? F. Good. If you have different colors, you might want to grab them. They might be helpful for while we're getting a hang of this. George. Okay. So, to explore this idea, I've got three functions for you. F of x is equal to 2x plus 3. G of x is equal to negative x squared plus 1. And h of x is equal to 5 over x minus 2. Okay, so look at number 1. Number 1 is asking me to find f of g of x. So, I'm going to let g of x be green. And I'm going to let f of x be blue. Okay. G of x is going to get plugged in to the function f. Okay? So where I see an x, I'm going to replace that x with g of x. So let's try. So the 2 is still going to be there. It's 2 times, in this case it was x, but what are we going to plug in for x? Good. We're plugging in g of x. So negative x squared plus 1. So f of x is 2x plus 3. So I've done 2 times my input, and then what am I going to do? Plus 3. You'll see that? Okay. From here, we're just going to simplify. So 2 times negative x squared is negative 2x squared plus 2 plus 3, which is going to give me negative 2x squared plus 5. So think about what we did. G of x was our input for f. So we took g of x and we plugged it in for the x and f of x. I'm okay with that. Okay, let's try it again. H of g of x. H of g of x. So this time, what are we doing? Good. Replacing g of x for x in the function h. So is the 5 going to change? So we're still going to have 5 over, what are we going to put in for x? Negative x squared plus 1. And then what? What else goes here?
-2.
Good, because it's 5 over x minus 2. So 5 over your input minus 2. Okay, now what do we do?
Solve.
Simplify. So this is 5 over negative x squared plus 1 minus 2, which is going to give us 5 over negative x squared minus 1. Questions on that?
Just simplifying the negative 5 over x squared.
Yes, that would be equivalent. Okay, let's try 3. f of x. f of x. What do you think?
2x plus 3 plus 3.
Good. So we start with our f of x, which is 2 times our input. But what's our input?
2x plus 3.
It's f of x again. So 2x plus 3. And then I add 3. So now let's simplify. So that gives me 4x plus 6 plus 3, which gives me 4x plus 9.
The next one, I'm doing that again. Counting
Hang on.
4x plus 9.
Okay, number 4 says f of 4. What is your answer going to look like?
A number.
A number, a value. No exit. It's not an expression. So there's 2 ways you can approach this. Okay, so the first way is to start working from the inside out. Okay, so the first way to try this is to first evaluate f of 4. What do you get when you do f of 4? How would I do that?
11.
How would I do that?
I'll put it into 2x plus 3.
Okay, so 2 times 4 plus 3. I'm plugging it into 2x plus 3, right? And what does that give me? 11. So now I wanted f of 4. Well, what did I just find out f of 4 was?
We found
11.
a new x.
So now we really want f of 11. Do y'all see that? All right, so let's see what f of 11 is. 2 times 11 plus 3, which gives me 25. Everyone okay with that way? You start by working in the inside and getting that value, and then plugging it into your other function. Okay, the other way to do this is we already found f of x, right? So couldn't we also just plug in 4 to this function? Yeah. You might not have already done that previously. You might have to go ahead and compose f of x and then plug in. But if you have it, that's great. So the other option would be to use this function right here and do 4 times 4 plus 9, which also gives us 25. Okay. Okay, so one of the reasons we talk about composition of functions is this theorem. If f of g of x is equal to x, and g of f of x is equal to x, then we know that f of x and g of x are inverses. So, say that again. If f of g of x is x, and g of f of x is x, then f of x and g of x are inverses. This is kind of what they meant when I told you when we talked about inverses that the two functions kind of undo each other. If you compose one and the other, and then do it the other way, they should both simplify to x if they are inverses.
So this should be, no,
The time when you will use this is when you are asked to prove by composition that the functions are inverses, or determine if the functions are inverses by using composition. Okay? If you see that word composition in there, it means we definitely want to see you do the two compositions, f of g of x and g of f of x. So I'll give you a second to finish writing that down. You raise your hand if you need more time. All right, let's try it. All right, so I want to determine by composition if the following functions are inverses of each other. So for number 5, I've given you f of x is equal to 4x minus 4, and g of x is equal to 1/4 x plus 1. All right, so I've got to do two things. I have to do f of g of x and I also have to do g of f of x. And when I simplify those both, if they both simplify to x, then our functions are inverses. All right, so let's give it a try. How would I write f of g of x? What would I do? Good. Everyone okay with that? Plug in g of x for f of x. All right, let's go ahead and simplify. 4 times 1/4 x is x. 4 times 1 is 4 minus 4. So what does that simplify to? X. Good. All right, let's try it the other way. G of f of x. G of f of x. What do I write here? 1/4 times 4x minus 4 plus 1. Good. Okay, 1/4 times 4x is x. 1/4 times -4, -1 plus 1, which simplifies to x. So what have we proven? Good. So you can use the little 3 dot thing. If you remember, that means therefore. We know that f of x and g of x are inverses. All right, would you please try 6? I would like you to prove or disprove using composition that f of x and g of x are inverses. right, so compare with your neighbor when you're done.
Yeah, because one is negative x minus 4, one is negative x minus 2. Yeah, because negative 1/3 times negative 3 equals 1 minus 3. No, but then you have to read it. Oh, it's not that.
So it's positive plus 1 minus 1, so there's
Yeah, I didn't get that.
but it's still, it's negative x and then negative x.
All right, are these two functions inverses?
No.
We did not get them, the two compositions to simplify to just x. So f of x and g of x are not inverses. Has to be positive x. Yeah, it has to simplify to positive x. Okay. I want you to think about this. Here are two functions. G of x is x plus 1. And f of x is the square root of x. I want you to talk about with someone sitting near you. Are you able to evaluate g of f of negative 3? So once you get it written down, talk about with someone next to you. Can you find that value?
X is negative 3. X cannot be negative. It's quadratic and
Talk it out with each other.
Yeah, it's
because x cannot be negative 3. No, but y is.
no, it's gonna find the radical of
Tell me how you multiply 2 times get negative.
All right, raise your hand if you think you can evaluate g of f of negative 3. Good. Why can't you? Brian, I heard you giving your explanation. Why can't you evaluate g of f of negative 3?
You can't find the square root of negative 3.
Yeah, we're not allowed to plug in negative 3 to f of x, right? What is the domain of f of x?
0. Bracket 0 is common.
Yeah, all x values greater than or equal to 0, right? This is a square root parent function. We are not allowed to plug in anything smaller than 0, right? So since negative 3 is not a part of the f of x domain, it can't be a part of the composed functions domain, okay? When you are dealing with composition of functions, you have to pay attention to both domains. And you have to make sure that whatever you are trying to plug in satisfies your domains. Because we cannot evaluate something that is not part of our domains. So what we would say is that this is undefined. And what would our reasoning be?
the radicand can't have a negative number.
Because of
Good.
the domain restrictions.
Yeah, all those are great because of the domain restrictions on f of x, because negative 3 is not a part of the domain of f of x, because you cannot take the square root of a negative number, however you want to define that to yourselves, okay? But make sure you understand that you've got to pay attention to both domains when you think about composition of functions, okay? All right, so I have a practice, little half sheet practice for you that I'm going to pass out in just a moment.